Thank you everybody for joining today's webinar, the 4 tenets of device identity, specifically what Smallstep does that nobody else can do regarding device identity in order to do device attested, hardware bound authentication to any of your network resources, single sign-on, effectively just making sure that only your corporate issued, corporate managed devices are even capable of accessing your most sensitive resources. So as part of this, Smallstep has built out our device identity platform. There's a handful of features here involved to really standardize and simplify hardware-bound device identity flows to your connecting clients, and basically give you a single pane of glass for certificate management, credential issuance, device health, and just general PKI and all those features around it that simply can be a little confusing, a little challenging. The Smallstep device identity platform basically wraps our open core PKI technology with the goal of simplifying device management for your IT operations groups, your IoT engineers, etc. And by the way, this is pretty free form. I have a deck here. I'm going to do a quick demo afterward. But please, if you have any questions, drop them in the Q&A panel. It should be here in the Slack options, and I'll go ahead and answer them as I see them come up. But for device identity, there's a handful of tenets that we have to follow in order to really get a grasp on our ecosystem. We've identified them to be inventory, credentials, configuration, and enforcement, ICCE. And there are reasons behind all of these, but effectively, we found that you can't realistically or reliably enforce your zero trust network flows unless you're hitting all 4 of these core tenets of device identity. It literally is the other half of zero trust. And so in most systems right now, maybe you say you have somewhere between 30,000 and 35,000 devices that can connect to Wi-Fi. If we're doing strongly authenticated device identity, we want to know an exact number of devices. And so oftentimes these devices land in disparate MDMs. Maybe they're unmanaged, but effectively we need them in an inventory to know these are the number of devices that we trust. We are cryptographically able to verify each of these anytime they connect to Wi-Fi, single sign-on, etc. From there, once we have a reliable, trusted inventory of devices, specifically the public keys from them, we can then use our core platform to roll out credentials to them. In this case, we use TLS certificates, public key infrastructure, all hosted from Smallstep, or we can actually extend an existing PKI. But our tooling will automate the certificate issuance, renewal, revocation, etc. of these certificates to the connecting clients. And to that end, it's also a matter of managing the certificates on the clients to be used. I know back when I used to be a security engineer, I would struggle with these certificates. What's the best practice from there? What does automation look like? How do I configure all of these devices to automatically shuffle these certificates from the TPM into a browser, for example, or configure WPA supplicant on a Linux device that's unmanaged? These are all very common challenges. And if you're not reliably managing the configuration on these devices, then you can run into a lot of usability concerns, help desk support tickets that might come up for Wi-Fi. And so we automate the configuration of endpoints. And then from there, it's simply a matter of enforcing all authentication to go through these hardware-bound credentials via a device that is in our inventory, configured by default by Smallstep's platform. And so let me jump into Tenet 1, inventory, because effectively the goal here is that we have to identify all of our corporate managed devices. To do this, we have to identify the EK or the AK public key. That stands for the TPM endorsement key, or the secure enclave attestation key in the case of macOS. Effectively, every device, every client-side device that has been built in the last maybe roughly a decade, minimum 5-8 years, has a TPM or a secure enclave. It is a cryptographic chip in the device that can do the signing operations and store these sensitive key materials. It ships from the factory day one with a private and public key etched into the hardware, unchangeable. And so if we can identify those public keys for all of our devices and get them into an inventory, we can do cryptographic attestations against the cryptographic coprocessor at the time of authentication. And so this can be a challenge. Chances are you probably don't already have a trusted inventory of device EKPub keys. You might have a device inventory or a handful of them in MDM, but they can be disparate. More often than not, they're not checking the hardware on a device. And so we have a few different enrollment mechanisms, starting out to get these devices enrolled to Smallstep for high assurance. Our most straightforward direct flow is agent-based MDM flows. And so we have a bit of a chicken and egg problem with our brownfield deployments. You probably have like a fleet of Windows devices in Intune, Mac and Jamf, name your MDM platform. So we can do a direct device inventory sync with MDMs, do a read-only pull of that data, aggregate that stuff in our system, and then from there we can do basically a SCEP-based challenge, a dynamic SCEP-based challenge between Smallstep and the device using the MDM as authentication. And then once we do that initial authentication via the MDM, we can simply roll out our agent. It's a lightweight binary built on Golang. It's a plugin to our open source client down to the device via MDM. And when you boot it on, it would authenticate via the credentials issued by MDM and then upload, report its EKPub key or AKPub key to Smallstep device inventory bound to a user with all the data that's synced over via MDM, also integrated into that device record. And so this is our most direct flow. Most people use this for brownfield deployments. And then from here to add more devices, you'd enroll them in your device. You'd enroll them in MDM, your device inventory. They'd sync over to Smallstep. Certificates would push. We'd roll out the agent, and it could do an attestation via the agent to upgrade to Acme DA. Now, for devices that aren't in inventory, I'm thinking perhaps like if you have a fleet of Linux devices, we have a handful of customers where they have tens, if not hundreds of thousands of like Ubuntu 2404 clients, none of which are managed, possibly brought in by acquisition or just like they're carving out exceptions for them. For those flows, we actually have a couple options. Number one is pre-registration via our API. So we have a full device inventory REST API and realistically REST API for our entire platform, where if you can query the public key and a user binding off the device using our tooling and upload that via our API, we can just aggregate these devices in inventory. And when they run the agent, they would boot up and automatically connect to Smallstep, do that cryptographic attestation, and start functioning as usual. So this is really popular with like more bespoke MDMs. I'm thinking like Rippling, they're an HR platform, but have some like MDM-ish integrations without being a full MDM. Or maybe if you're using group policy objects through AD, we don't have like they're not direct MDMs. And so this flow is also really popular where you can manage the device. Like you can push out scripts, you can push out packages, but like nothing else. This flow comes in handy. And then we also have a user-based enrollment flow. This is turned off by default, but thinking perhaps you or your directors drop your laptop in a lake during a company outing and you have to hop on this important investor call in the next hour. There's a pretty straightforward route. Your director could go out to the Apple store, buy a new device, contact IT, and we can actually kick off a single sign-on flow against your identity provider, running the agent directly on the device. That will single sign on against your IDP, onboard them to Smallstep, and then from there, there is an approval phase required from your IT administrators to go in and say, I have so-and-so on the phone. This isn't some random device. I trust it. And they can go in and approve the device, and it will upgrade to Acme-based assurance, start issuing credentials. And so those are the three primary inventory integrations we have to get our structured device inventory. But once we have this aggregated, it's simply a matter of pushing out our agents and issuing credentials. This tends to be half the battle since your average organization isn't already tracking EK keys, but we have several solutions that can do that. Longer term, if you use, say, Lenovo, Dell, Intel, CDW, we do have OEM integrations for our larger enterprisey customers where they can just drop ship laptops and we get the EK pub key automatically. So next up, Tenet 2 is credential issuance. The devices are in inventory. We know they're EK pub keys. We can track them and we have communication down to them. At this point, it's a matter of getting certificates on the device or authentication effectively to our networks and as additional factors. To do this, the core of our platform is actually our open source STEP CA technology. It's been out for roughly 10 years. Our whole platform is open core built around that functionality. So our core platform can actually run as many highly available certificate authorities you might need on demand. They can scale up, scale down, add additional provisioning mechanisms, add additional policy, active revocation, and like a handful of dashboardy admin type features that you might want to see. So at the core of this, we are running PKI for you. And we can run this in a highly opinionated fashion that really we can get on a call and solution out if you have custom requirements. But as part of this, we've been doing work for credential issuance over the last couple of years with Google. We've been collaborating to implement the device attest 01 challenge type to the Acme standard. So the Acme standard was rolled out by Let's Encrypt back in the late 90s, early 2000s. It is very, very popular for server issuance of certificates. So for example, if you go to GoDaddy, Let's Encrypt, DigiCert, and ask for a public certificate for your domain, they'll give you a text record, a little challenge. You'd upload it to your DNS records as a text record. And then when it validates by the registrar, when it becomes discoverable, you've officially proven that you own the domain, or at least that you have access to the domain. And so we've been extending this protocol to also be able to do this challenge against a TPM or secure enclave, given an inventory of trusted device keys. And so using this given protocol, we can just run this against our authorities as is. So when devices boot up, the agent can make an Acme client call out to Smallstep's attestation authorities. Our Acme server would respond with the challenge, do the encrypt, decrypt handshake, and then out of that, we've proven cryptographically with a mathematical proof that the device connecting, requesting for this certificate actually is a given, it's coming from a TPM. And so you know with high assurance that the connecting device requesting this credential actually is managed by your organization, and that it's not some device that they're bringing in from their gaming PC or on a friend's laptop if they need to single sign on to email. This would require that hardware as the actual component for authentication, because following this authentication challenge, we take the credentials, pop them right back into the TPM or secure enclave, and then from there, they're bound to the device. So these devices have non-exportable keys, they become phishing resistant, and effectively, to my point earlier, it allows you to enforce policy instead of just having a hand-wavy legal requirement. You can actually force engineers to follow your policy to use a company-managed device. And so there's a handful of other ways that we can authenticate requests, but Acme device attestation is our North Star. We've specifically worked with Google to implement this extension to the protocol to solve a couple challenges with traditional enterprise-grade PKI, such as Active Directory certificate services, or realistically any CA that you'd have behind your MDM to issue certificates. So the technology that we're replacing, we consider to be legacy. It is SCEP, SCEP, ADCS, and MDMs like Intune, Jamf, etc. By default, they use SCEP-based challenges. And chances are, if you're using certificate-based authentication to Wi-Fi, VPN, you're probably using a SCEP-issued certificate today. And so how that works is your MDM will push down a password to the device. The device will then exchange that password for a credential and then use that credential for authentication. There's no way of proving that that password was run from that device. And even if it was, the credentials get saved to the disk. And so, unless you're doing some really strong protections, there's almost nothing stopping your end users from popping in a flash drive or sending an email with these client credentials to their personal device where they can impersonate like the origin device. And so by tying this into the cryptographic coprocessor, we have a high assurance way of issuing these credentials, but also proving that they are still on the device they were issued to. So we have the devices in inventory, we have credentials on them. Now it's just a matter of connecting them to whatever services we need to connect them to. And so at the core of this, we're using TLS certificates. And that means that this will work with effectively any technology that will support TLS-based authentication, whether that be Wi-Fi networks, wired Ethernet, VPN, ZTNA technologies, or even as additional factors of authentication for Okta, Enter ID, Google Workspaces. And so that's just a handful of capabilities. Realistically, anywhere that you're using certificates from the client side, we can just use the device-bound credentials now. And to do so, we can actually control this in the Smallstep platform as a control plane feature, where we can set up a number of protected resources that the agent, when it reports to Smallstep and does that attestation, can pull down a configuration for a subset of resources they have access to. So when the device boots up, it would run the agent as a login item. You'd configure this via MDM. And when it boots up, it pulls down a JSON config from Smallstep with the resources that it has access to. And from there, it'll do attestations against any relevant certificate authorities, issue the certificates to the TPM. And then from there, the agent will automatically load them into your browser, load them in, like set up WPA supplicant for Wi-Fi, set up a Wi-Fi or set up a VPN payload. All of this on your behalf. And so following this, the idea is your end users don't actually know anything's happening. They boot the laptop, the agent kicks off in the background, invisible to the user. As I said, it's a lightweight Golang binary, just a plug into our open source. So it's not like a dashboard item icon. This is a background service that will run, issue the credentials, and then automatically connect them to Wi-Fi or what have you. So from the end user's perspective, they boot up their laptop, and then it connects to Wi-Fi, all via the agent really managing these certificates and their life cycle on the clients. And then from there, the client's done. It's just a matter of configuring your enforcement points to require these hardware-backed certificates. So we're only allowing these devices to authenticate with these ACME-DA credentials. From here, it's a matter of configuring Okta, configuring Enter ID, configuring your Radius servers or your proxies to use these certificate authorities as authentication. And then implicitly, because these are only capable of issuing ACME-bound credentials, we have this implicit requirement during authentication that it has to come from a managed device issued an ACME-DA credential. And so, as I mentioned, you would just set up the given features in Okta. We'd set up as an additional identity provider. For Wi-Fi, you'd set up the Radius server. For proxies, you'd set up the proxy server. And as far as that goes, if you have something in place that we can integrate into, great. We have direct integrations with your average Radius providers like Aruba ClearPass or Juniper Mist, Cisco ICE, VPNs like Global Protect, VPN, etc. But if you do need some additional infrastructure for this enforcement point, we do have a few options that we can also provide from an infrastructure stance. So for Wi-Fi, if you don't already do enterprise-grade Wi-Fi or you're not super happy with your Radius provider, we can actually run a Radius server on demand for you as part of the platform. So we can drop any number of Radius proxies anywhere around the world for low latency Wi-Fi connectivity. And so if you were to go with this platform, you wouldn't need an external Radius provider unless you want. Additionally, we've had some users ask for like a ZTNA solution or a tunneling approach. But historically, Smallstep hasn't been super keen on inspecting traffic or like watching tunnel traffic. So we've been working on what's called an enterprise relay. We have a lightweight identity aware proxy. This is based on the MASQ protocol, MASQUE, used by Apple's iCloud Relay. So it's super quick. It's using these hardware bound credentials from the client side. The agent can function as a proxy client in between the TPM and the relay. And then from here, you can set up a static egress IP for GitHub or Slack and implicitly require all connections to originate from this proxy's endpoint. And then we also have an SSH solution where we can do SSH PKI, where we can manage access to the hosts via host side user and group management, access control group synchronized down from your identity provider, and then manage user credential issuance. This can tie as well into our hardware bound device identity platform, where our agent can actually shuffle these SSH credentials to the TPM as well, pulling them out during our SSH authentication. So in this given flow, we'd be able to replace the SSH agent on your connecting clients with ours and make the credentials hardware bound. And so high level, just in recap, we are covering the inventory, credentials, configuration, and enforcement components of device identity. We believe this is to be the other half of zero trust. And what this allows you to do is strongly authenticate all of your devices to effectively make sure that only the ones that are under management and you have records of their hardware are capable of accessing your most sensitive resources, regardless of what that might be. And so that concludes my slide deck component of today. I'll move over to an actual demo. If you have any questions, please pop them in the Q&A chat here. I'll go ahead and discuss them as we go through here. But in the meantime, let me show you what this looks like in practice. So from an inventory standpoint, we have direct inventory integrations. Here I have a couple set up with Jamf and Intune. I have a couple unmanaged Linux devices in here as well in my testing tenant. We have integrations directly with Jamf, Intune. There's a handful of others that I don't have enabled on this account, but on this one, I'm using Jamf and Intune. And that would pull over a device inventory of the device's metadata. The device I'm on right now looks like this. We can see that it is currently running the agent. It has an active certificate. And I have the AK pub key in my inventory here. Quick question in the chat. Is there a tenant that is most important? Arguably, they're all equally as important. In terms of priority, though, I would say device inventory, because at the core of all this, we do need that source of truth of the devices that are authenticating to your network. The inventory stands as that number one requirement to do ACME DA-based authentication of certificate issuance. In theory, you could just use MDM or use scripts or have the user independently configure their client to use the credentials. Shy of our agent, you can do it via the MDM. High level, that's my long way of saying the inventory component is arguably the most important, but you kind of have to have all four in order to streamline authentication in a user, in a good UX flow. Please let me know if that didn't quite answer your question. So here's the AK pub key. And here, ahead of this demo, I went ahead and rebooted my computer to get the login item to restart my agent. We can see here, about 28 minutes ago that was, we received an attestation for this AK. This is the attestation key for this MacBook for my secure enclave. This is etched into the hardware of my secure enclave. So my device was onboarded via Jamf, upgraded to ACME DA via the agent, and then from there, it's doing all authentications to Smallstep via an ACME request. And so here's that cryptographic attestation that it logged in successfully. And we're showing green that has healthy certificates. It has all the configurations down that it needs. And to check the certificates that were issued, these are secured in the secure enclave. So there's actually a caveat on macOS. Each operating system kind of has its own caveats with how they manage their TPMs or like hardware bound keys. So that's part of the reason we had to write the agent to get it to work cross OS. With macOS, it's actually natively supported, the Acme challenge. But what that means is from the device, you can't actually see these credentials being issued because they're secured in the data protection keychain, invisible to users, only accessible via the kernel space or a PKCS11 connector. And so to look at these certificates issued to Mac, I actually pulled up our certificates and searched for this given device. We can see this was the credential, well, from the former attestation issued to my device, the Acme device attestation with the following attributes. And so now I trust that this device would be able to do what it needs to do. From the protect standpoint, I have a handful of resources configured. We can set up Wi-Fi, VPN, ZTNA single sign-on. This will tell the agent what criteria to pull down and will automatically assign these records to any devices that meet their policy set. So for example, this one's applied to my Linux devices that have done an attestation. This device will not get this configuration. But this is how we tell the agent what to do. Client side, this is as far as an admin would need to care about. Client side, let's show how this works. So I started up the agent ahead of this call. What it did is it did the attestation, and here you can see it automatically loaded these certificates into my browser. And so anywhere that I'm using these, it should now be accessible via Chrome. And so this would work in Chrome, Firefox, Safari, Island, realistically anything that supports browser-based TLS. You can see here as my second factor, it's requiring that I verify with Smallstep. This will check that I have a hardware-bound credential that's also been stored in my browser. We can see that it has. This is coming from a corporate managed device. It's using my identity certificate here. And so there, it completes the second factor for sign-on, and I now have access to my repository. And so that's an example of using it with Okta. It's just a second factor for Okta. You can see here, I actually have an additional configuration for Enter ID. And so I'm doing something similar there with Microsoft Admin Portal. So that secured like the web browser login for Git, but what about everything else? We have personal access tokens, we have Git-based authentication, and those were not solved by this Okta integration. With the PATS use case, we can actually set up an enterprise relay to proxy traffic and set up an IP allow list to require PATS to come from that tunnel. For Git authentication, we have that direct SSH integration for authentication. So right now, my browser's authenticated. My client actually isn't my terminal. So let me just show you what it looks like to try and clone this repository from an unmanaged device, because I do not have my terminal yet authenticated. So I don't have them loaded. And so you can see I don't have the correct access rights. Let me log in. And so this will pull my device-bound credentials into my terminal, where I'm doing an additional sign-on check via Okta. This would work with any identity provider. Okay, I have the credential issued. Let me inspect it. There's a certificate that wasn't there a moment ago. And here I'm using the STEP toolchain. This is our open source client. It's basically our replacement for OpenSSL that does tie-ins to our authorities and some other cryptographic commands. But here I have an SSH inspect command. Our platform automatically included my GitHub login as an extension on my certificate, which means I can use this to authenticate to any GitHub enterprise that trusts this given certificate authority via this username. So now that I have that, let me go back to clone that. Let me remove that. Okay, there it's successfully cloned. We can see the README here. So it did, in fact, pull this repository down, authenticating via my device bound SSH credential issued by Smallstep via single sign-on. And so there's a few layers in here. We're doing a couple layers of authentication. I'm doing user authentication via Okta while simultaneously doing my second factor as my hardware-bound Acme DA certificate on this device. And so, for example, requiring these second factors would force GitHub logins, Git authentication to only come from trusted devices that are in inventory where we do have your device public key and can do that authentication. But from an end user's perspective, they just go through their normal workflows and our tooling will kick on, do those attestations, issue the credentials, and then automatically connect them where they need to go, as we saw in the case of Okta. If I were to extend that Wi-Fi configuration to also apply to macOS, this device would then also pull down that Wi-Fi configuration and then try to join that SSID. I won't do that today because I will get kicked off this webinar, but the same idea would apply for other protected resources, other connecting devices. You would add them into your MDM, they'd sync over and have the device, the protected resource configurations automatically mapped to them. And similarly, if you have a new VPN server set up or you want to add somebody, like add a new production server, you just add a new protected resource for them in here, scope it out to the relevant devices, and then they would pull down that configuration and then connect to the resource. And so we have the device inventory, we have the credentials being issued, we have the configuration layer, and then enforcement in this instance, I'm using Okta and SSH as my enforcement points. And high level, that is how Smallstep can help you enforce device identity for everything using our 4 core tenets of device identity: inventory, credentials, configuration, and enforcement. If you don't have all 4, we don't believe that you have what we consider to be high assurance device identity, where you can cryptographically prove connecting devices are those devices. Or alternatively, with password-based protocols, you can make your strongest guess. You can have EDR and tooling to try and like do reporting, but there's really no way of providing actual proof of devices connecting without actually doing this attestation with the hardware. Thanks so much for joining the webinar today. If you're interested, I believe the one next month will be specifically tailored to Jamf, macOS, and iOS, and kind of our native integration and partnership with them. So if you would like to see anything more on like that side of house, go ahead and join us in a month. We'll send out an email reminder to the people who joined today. And I look forward to seeing you then. Thank you, everybody.